Good morning, everyone. Uh, Today we'll discuss some numerical problems on second module, that is short circuited analysis, symmetrical short circuited analysis. So, in that, okay. So take this problem. Example one. It is a synchronous generator and motor are rated for 30,000 kVA, 13.2 kV, and both have subtransient reactance of 20%. The line connecting them has a reactance of 10% on the base of machine rating. The motor is drawing 20,000 kilowatt at 0.8 power factor leading. The terminal voltage of the motor is 12.8 kV. When a symmetrical three-phase fault occurs at motor terminal, find the subtransient current in generator, motor, and at the fault point. So this is the question. Note down the question. So the generator is there and motor is there. Generator and motor. Generator having 30,000 kVA. Okay, that means 30 MVA, and this one is 20,000 kVA motor, and synchronous and 13.2 kV, both have subtransient reactions of 20%. So in both the case 13.2 kV is the voltage. Here also 13.2 kV, and the reactances are 20%. So J.2, and this one is also J.2, and the line reactance in between connected between generator and motor, that is 10%, J.1. So the motor is drawing 20,000 kilowatt. Okay, both generator and motor rated 30,000. So motor rated is 30,000, but this is the capacity of the motor is 30,000, but it drawing the power of 20,000 kilowatt. Okay, so 20,000 kilowatt. This is the drawing power at 0.8 power factor lagging. So while calculating the current, this is important. Calculating the actual current of the motor. So this is important. Okay. The terminal voltage of the motor is 12.8 kV. So terminal voltage of the motor is 12.8 kV. So capacity is 13.2 kV, but terminal voltage is 12.8 kV. When symmetrical three-phase fault occurs at the motor terminals, symmetrical three-phase fault occurs at motor terminals. The fault occurs at this terminal, this point. motor terminal. A fault occurs here. Motor terminals. Find the subtransient current in generator. What is subtransient current? I double dash. Right? That is the subtransient current in generator and motor. So that is Ig double dash and Im double dash. Subtransient current is to be calculated. Okay, at the fault point, at the particular fault point. Okay, so draw the reactance diagram for this single line diagram. So generator is represented by Eg at an Eg with a reactance that is J.2. Similarly, the line reactance is J.1 and motor reactance J.2. Okay, and the fault occurs at the point at the terminals of the motor, that is point F. Okay, and current flowing through this circuit is IL, and voltage across the motor at the fault point is VPF, and the subtransient voltage of generator is Eg double dash, and subtransient voltage behind the subtransient reactance, that is Em double dash. Okay, this is the reactance diagram or the equivalent circuit of the system in the subtransient period. So for the calculation of pre-fault voltage, so VPF, that is before fault, we need to calculate first. Okay, all of you following this? All of you following? Is it audible and visible?
Yes, sir.
Okay, so you understood the question, right? What is to be calculated? Okay, so now the values of voltage sources are subtransient internal voltages. So let's consider the base values. So base values we need to consider. So in this question, the motor and 30,000 both that is given, and is not represented any base values. So therefore we need to assume the base values. So generally the highest value is taken as the base value. Okay, so that is generator value, that is 30,000 MVA. 30,000 kVA, that means 30 MVA. 30,000 kVA means 30 MVA. So MVA base is equal to 30,000. So that is taken as base. So 30 MVA for generator, and 13.2 kV. 13.2 kV, that is the voltage taken as base for generator side. Okay, so the pre-fault voltage at the fault point, that is VPF, that is given 12.8 kV. So 12.8 kV is across the fault point, that is VPF at the motor terminals. Okay, so now let us use this as a reference phasor per unit value of the pre-fault voltage. So we need to calculate it is in terms of per unit. So VPF is equal to actual value by base value. Base value is taken as 13.2. Base value is taken as 13.2 kV. So therefore actual value by base value in the motor side 12.8 kV divided by 13.2 kV, and your VPF is equal to 0.97 per unit. VPF is equal to 0.97 per unit. Okay, so now calculate the base current. So base current is equal to base power divided by root 3 into base voltage. What is your base power? 30 MVA is the base power. So 30 into 10 raised to 6 divided by root 3. So what is the base voltage? 13.2 kV is the base voltage. 13.2 k means 10 raised to 3. So calculate this. So we will get 1312 ampere. All of you having the calculators, do the calculation. So that is 1312 ampere. All of you got this answer?
Yes, sir.
Okay. Similarly, you need to current load current IL. So IL, that is called as actual value of the current, and base value of the current. Base value of the current calculated by MVA by kV square, kV root 3 kV. So that is the base current, and we need to calculate actual current, that is IL flowing here. So that is given by, so how much motor is drawing. So how much motor is drawing current? The drawing the power, that is 20,000 kilowatt, means 20 megawatt. Okay, so 20,000 kilowatt. So divided by root 3. So here both are in kk. Kk get cancelled here. 12.8 k and 20,000 kilowatt. Okay, so kk get cancelled. 20,000 divided by root 3 into 12.8, and power factor is also given, 0.8 power factor for the motor. So 0.8, and if you want to calculate the angle, cos inverse of 0.8, this will gives the angle. So calculate this IL value, you will get 1128 at an angle 36.9 degree ampere. Got this?
ಸರ್ 20,000 ಮೆಗಾವ್ಯಾಟಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಂಗಿಲ್ಲ ಸರ್ ಮ್ಯಾಗೆ?
ಎರಡು ಒಂದೇ. 20 ಮೆಗಾವ್ಯಾಟ್ ಅಂದ್ರೆ ಏನಾಯ್ತು? 20 ಮೆಗಾವ್ಯಾಟ್ ಅಂದ್ರೆ 20 ಇಂಟು 10 ರೈಸ್ ಟು 6 ಆಯ್ತು. ಓಕೆ, ಡಿವೈಡೆಡ್ ಬೈ ಇಲ್ಲಿ 12.8 ಇಂಟು 10 ರೈಸ್ ಟು 3 ಆಯ್ತು. ಎರಡು ಸೇಮ್ ಅಲ್ವಾ ಆನ್ಸರು? ಅಲ್ವಾ? 3 ಹೋಯ್ತು, ಇದರಲ್ಲಿ 3 ಉಳಿಯಿತು. 20 ಇಂಟು 10 ರೈಸ್ ಟು 3 ಅಂದ್ರೆ 20,000. ಕರೆಕ್ಟ್ ಅಲ್ವಾ?
ಎಸ್ ಸರ್. ಎಸ್ ಸರ್.
Okay, so next, so now load current in per unit. Calculate load current in per unit. So per unit is equal to actual value by base value. Actual value of the current is 1128 divided by base value of the current is how much? 1312. So actual value by base value. So base value at an angle 36.9 degree. This is at an angle 0 degree. This is at an angle 0 degree. Okay, so therefore this will becomes how much? Convert into polar form, we will get load current is 0.8594 at an angle 36.9 degree. Now if we got this answer, so load current IL calculated now, that is 0.85 per unit. Point 0.85 per unit, right? That is load current IL. So there is there are two methods to find out that is subtransient current. One is using Kirchhoff laws, second one is using Thevenin's theorem. Okay, so both the method we will discuss today. So by using Kirchhoff laws, the subtransient voltage Eg double dash and Em double dash is calculated by Kirchhoff voltage law. Okay, go to this diagram, Eg double dash and Em double dash. First one is taken as Eg double dash. So what is Eg double dash? Eg double dash is equal to apply KVL here. Okay, that is IL is flowing J.2 IL plus J.1 IL. Current flowing through this J.2 into IL plus J.1 into IL plus this voltage. Okay, or plus J.2 into IL plus EM double dash. So that is the equation. So here VPS is directly known 0.97 here to here. Voltage drop is, that is, we already get. So instead of taking these two into IL, so that already it is uh, find out. VPF is find out. So J.2 into IL plus EM double dash is equal to VPF. So that is 0.97 per unit. So instead of that, directly taken 0.97 per unit here. So that is VPF. Is it clear? J.2 IL plus J.1 IL plus VPF. This is the KVL. That is equal to EG double dash. Is it clear? ಅರ್ಥ ಆಯ್ತಾ? ಯಾರಿಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಕೇಳಿ. KVL, apply KVL. So apply KVL like this. So what is the current flowing here? IL. So IL into J.2. So EG double dash is equal to EG double dash. So they entering towards negative. If you take outside, this will becomes positive. EG double dash is equal to, this is IL into J.2 plus, so IL into J.1 J.1 plus, so you can write IL into J.2 plus EM double dash. So that is equal to VPF. I will write IVPF directly. So this is the KVL for EG double dash, right? So J.2 IL plus J.1 IL plus VPF. So IL is known, that is in terms of per unit you have calculated. Substitute directly here, 0.2 into, so J is written as plus 90 degree, or you can directly take using in a complex form, J.2 into 0.8594 plus J.1 into 0.8594 and VPF. VPF is how much? 0.97 at an angle 0. 0.97 at an angle 0. Multiplied by that current. Current also you have to multiply here. 0.8594 at an angle 36.9. So this is the current. This is the current. This is 0.1 and this is 0.2. And this J is represented as 90 degree here, and this J is represented as 90 degree here. Is it clear? So calculate this. How much you will get? What is EG double dash? What is EG double dash? 0.84 at an angle 14.2 degree per unit. If you got this answer, Shabiha Attar, Mahesh Kumar SK, Mahesh Kumar, Rajahatti.
Yes, sir.
Got the answer? Mahesh. Rajini.
Yes, sir.
Yes, sir.
Okay. Similarly, you calculate EM double dash. So EM double dash is equal to VPF minus J.2 into IL. EM double dash is equal to VPF, this VPF minus J point
Yes, sir.
2 into IL. What?
Yes, sir. Got, sir.
Okay. So voltage across the EM, that is VPF, VPF minus J.2 into IL. This will give EM double dash. It means voltage across EM. I want. So VPF is there. VPF minus J.2 into current flowing through this. So this will give EM double dash. So total voltage is there. Voltage across EM double dash and this reactance. Okay. So if you want voltage across EM is equal to this VPF minus of this voltage drop across J.2 voltage drop. Okay. So therefore VPF minus what is the voltage drop across 0.2 IL into J.2. This will give EM double dash. So calculate it. VPF is 0.97 per unit. J.2 into IL is 0.8594 at an angle 36.9. J is written as plus 90 here. Otherwise, you can directly take J in your complex form and calculate it. How much you got? Do it fast. So the problem is very vast. So first method is you need to calculate through via Kirchhoff law, and second method you need to calculate through Thevenin's theorem. Okay. Give the response very quickly. Got EM double dash value?
Yes, sir.
Okay. So now you draw the equivalent circuit of the system. Okay. For the three-phase fault occurring. Okay. In previous case, we have written pre-fault circuit diagram. Now you have to write three-phase fault that is showing in the below diagram. Okay. So fault occur means there is a short circuit occur. So repeat the same diagram. Okay. At the VPF, at the point of VPF, draw the short the terminals. So because here fault is occur, short the terminals. Okay. So now what happens? So IG double dash, the current here that is flowing like this, Ig double dash, and Im double dash is flowing like this. Total current will be If double dash, that is flowing in the fault point. Okay. Total current If double dash is flowing in the fault point. So the subtransient fault current If double dash at fault point computed by summing up the transient fault current of generator Ig double dash and subtransient fault current Im double dash, right? So Ig double dash and Im double dash. So therefore applying KVL to the circuit, so that is Eg double dash is equal to J.2 Ig double dash plus J.1 Ig double dash is equal to Eg double dash. Okay, Eg double dash is equal to 0.2 J and 0.1 J into Ig double dash. This will give Eg double dash. Okay, so calculate Ig double dash is equal to Eg double dash by J.3. How much it is? So there are two loops here, loop 1 and loop 2, right? So same thing, apply KVL here. Ig double dash is flowing, right? Apply KVL here. So 0.1 plus 0.2 J.3 Eg divided by J.3, this will give Ig double dash. How much it is? Eg double dash is 0.84. That is you have calculated here. 0.84 at an angle 14.2 divided by J.3. J means 90 degree. Okay. So calculate it. Ig double dash 2.8 at an angle minus 75.8 degree per unit. You got Ig double dash is equal to 2.8 per unit. Similarly, calculate Im double dash. What is Im double dash? Im double dash. So J.2 is there, Em double dash is there. Im double dash is equal to Em double dash divided by J.2. Okay. Em double dash is 1.08. That is now calculated 1.018 at an angle minus 7.3. Right, divided by 0.2 at an angle 90. It means J.2. So calculate it. Im double dash is 5.4095 at an angle minus 97.3 degree per unit. All of you got this? Im value, Im double dash value. Once Ig double dash and Im double dash are found, so calculate If double dash. What is If double dash? Is the summation of Ig double dash and Im double dash, like this, right? So what is If double dash now? If double dash is equal to these two, 2.8 angle 75.8 degree plus 5.4 at an angle minus 97.3 degree. So calculate this, you will get the value. If double dash is 20. So if one actual per unit, what is current? IL per current is base current. Actual value is equal to per unit into base value. Okay. So the answers you have got Ig double dash and Im double dash and IF double dash in per unit. So per unit into base value, this will give actual value multiplied by actual value 1132. Multiply this 1132. Calculate it. So multiplied by 1132. Right? Sorry, 1312, not 1132. 1312. 1312. Calculate it. How much you got? So you know base value is equal to the per unit is equal to actual value by base value, right? Per unit is equal to actual value by base value. Now I want actual value, right? So therefore per unit is calculated here. So cross multiply per unit with base value. Base value is 1312. That is calculated here. 1312. That is the base current. So multiply with that base current to the Ig double dash, that is in per unit. You will get actual value. Similarly, Im double dash of actual value also you get multiply with 1312. Similarly, fault current actual value if you want, you multiplied with 1312, that is base current. How much it is? Anybody? Tell the answer quickly. Mahesh? Halesh?
Calculating, sir.
Do it fast.
Yes, sir. Yes, sir.
What is the answer, Mahesh? Arvind?
Yes, sir.
What is the answer?
Calculating, sir.
Ismaya? Calculated?
Sir, IG double dash
How much?
3673.6 at an angle minus 75.8 degree.
3673.6 at an angle minus 75.8 degree. Im double dash?
7097.264 at an angle minus 97.3.
Okay, correct. If double dash?
10581.2 at an angle minus 90.
Okay. So these values you got through Kirchhoff voltage law method. Okay. Now same thing we can also obtain through Thevenin's theorem method. Okay. Second method is Thevenin's theorem method. Okay, you can calculate by using two methods, that is symmetrical fault analysis. So first method we have calculated. First we have to do base values and reactance diagram and calculate the VPF, okay, everything, and calculated the IL. After this, by using Kirchhoff voltage law, Eg double dash and Em double dash is calculated, and fault current, that is shorted the current at the fault point, shorted the line at the short point, So calculated the IF double dash, that is IG double dash plus IM double dash. So this is one method, and after calculating that, per unit is converted into actual value by multiplying the base values, right? So second method is by using Thevenin's theorem. So what is the Thevenin theorem says? So that is Thevenin voltage VTH and Thevenin impedance ZTH. Okay, we need to calculate Thevenin's impedance, that is ZTH. Okay, VTH, that is already there. So this is VPF is the VTH at the fault point. The terminal voltage at the fault point, that is called as VTH here. Okay, so that is 0.97 per unit, that is already calculated. So VTH is known 0.97 at an angle 0 per unit. Okay, and calculate the ZTH. While calculating the ZTH, we need to short all the voltage sources and open all the current sources. That is the Thevenin theorem. Okay, so in your reactance diagram, short all the voltage sources, previous diagram before pre-fault. So EG double dash, that is short this, and EM double dash short this. Okay, and J.2, J.1 and J.2. Okay, you got three individual reactances and make it as fault point like this as it is F. Okay, so we need to look at from the fault point. Okay, we need to look at from the fault point. So what are the parallel things? So current will be dividing like this. Okay, so we look at from the fault point means, so for analysis purpose, so you are looking like this means current flowing like this in this direction. So it means these two and this one are in parallel. 0.2 plus 0.1, 0.2 plus 1, that is, so this is 1.0, not 1.0, this is J.10, right? 0.1 plus 0.2, this will become 0.3, and this 0.2 is parallel with this combination, right? J.2. If this point is not there, then all are in series. If F point is, this node is not there, then all are in series, but it is not series. This point is there. So therefore, these things are in parallel. Is it clear? Okay. So write the diagram like this. Fault point is like this. Okay. J.2 is parallel with this 0.3. You can also write this diagram like this. So analyze ZTH now. 0.3 and 0.2 are in parallel. So ZTH is equal to Z1 Z2 divided by Z1 plus Z2. 0.3 plus 0.3 into 0.2 divided by 0.3 plus 0.2. Calculate this. You will get 0.12. That is your ZTH. So draw the equivalent circuit of Thevenin theorem. There is voltage source in with, that is VTH, in series with the ZTH. Okay, that is your Thevenin theorem equivalent circuit. So draw the equivalent circuit, that is Thevenin equivalent circuit of the system with respect to the fault point. So fault point is here. This is the voltage source, that is VTH. So that is 0.97 per unit. ZTH is J.12 per unit. Okay, so we got Thevenin equivalent. So for Thevenin equivalent, now for the fault analysis. So we have calculated pre-fault analysis up to here. Now calculate fault analysis. Fault analysis means fault occur, short this terminal at the fault point. So now fault current is flowing, that is called as IF double dash. How we will calculate IF double dash? That is the current. Very simple. VTH divided by ZTH. So VTH 0.97, ZTH is J.12. So calculate this, you will get 8.06 at an angle minus 90 per unit. This is IF double dash. 8.06 at an angle minus 90. 8.06 at an angle minus 90. Right? Same value got while calculating in the Kirchhoff law. Whatever the final value you got here, IF double dash, the same thing you got here. 8.06 at an angle minus 90. But from this, we need to calculate EG double dash and that is IG double dash and IM double dash. For that, to find out subtransient fault current in motor and generator. Okay, when the fault occurs, there is a change in the current supplied by the motor and the generator. This change is calculated by connecting the Thevenin's voltage with reverse polarity. So this is we need to know. Okay, this is one procedure while finding through the Thevenin's theorem in the symmetrical fault analysis. Okay, so this is the procedure. Keep in mind, fault occurs, there is a change in current supplied by the motor and generator. This change is calculated by connecting Thevenin's voltage with the reverse polarity at the fault point, that is as shown in the figure. Okay, so this VTH will connect in reverse polarity. Actual polarity is 0.97 plus and minus. We have changed in reverse polarity minus and plus, and write your equivalent reactance diagram. J.2 for this is for generator, J.2 for motor, and J.1 is line. So this is I1 is flowing like this, I2 is flowing like this. Okay, but only thing is VTH is in reverse polarity. So calculate I1 value and I2 value. I1 is equal to 0.97 divided by J.2 plus 0.1. Okay, we will get I1 is equal to 3.23 at an angle minus 90, and similarly I2 is equal to 0.97 divided by 0.2. So 4.85 at an angle minus 90 degree. Right? So the subtransient fault currents of the generator and motor, that is to be calculated now. IG double dash is equal to IL plus I1. IL plus I1. So this I1 plus your load current in per unit. So what is load current in per unit? 0.8594 at an angle 36.9. 0.8594. Previously we have calculated. This is not 0.8594 here. Before Kirchhoff law, you have calculated 0.8594 at an angle 36.9. So multiply with the load current and plus, sorry, not multiplication, that is adding. So IG double dash is equal to IL plus I1. 0.8594 plus 3.23. Take angles also. You will get 2.8 at an angle minus 75.8 degree per unit. That is IG double dash. To compare that IG double dash in the previous method, is it same? 2.8 at an angle minus 75.8 per unit. Same value you got, right? Similarly, IM double dash is equal to I2 minus IL. IM double dash is equal to I2 minus IL. So this is I2 minus of IL. How much it is? I2 is 4.85. Calculated here at an angle minus 90. Minus of IL, right? 0.8594 at an angle 36.9 degree. Calculate this, you will get the answer 5.4 at an angle minus 97.3 per unit. Okay, so IM double dash, you compare with the previous one. So IM double dash, same answer, 5.4 at an angle minus 97.3, right? So once you calculated these things, thus we find that current calculated by both the methods are same. The absolute values of current can be obtained by multiplying the per unit value by base current. Okay, same, repeat that procedure. Subtransient fault current of generator Ig double dash is equal to, that is 2.8 at an angle 75.8 multiplied by your base value is 1312. Calculate it, you will get 3673.6 at an angle 75.8 degree. That is the ampere. This is unit is ampere. Actual value unit is ampere. Per unit value unit is per unit. So subtransient fault current of motor, similarly calculate, multiplied by 1312, you will get 7097.2 at an angle minus 97.3 degree. And subtransient fault current at the fault point of IF double dash, summation of these two, that is you have calculated 8.065 at an angle minus 90 multiplied by 1312. How much it is? 10581.3 at an angle minus 90 degree. So this is the solution for this problem. Any doubt regarding this problem? Hmm? Hello? Is it clear? Or if you got the answer?
Yes, sir.
Okay. We will stop today's class. Already time is over. Okay. Okay, we'll again discuss on Monday. So before Monday, all of you write your assignment and send it to my email ID. Okay. So similar type of problems, and another topic is there, that is selection of circuit breaker. So that is we'll do in next class. Another 3 to 4 classes is required to complete this module. So this module is very uh, compared to the previous model. So this is topics are very less. Okay, you can easily complete this module. Okay, so thank you very much.